Hello guys, it's me again. Now it's time to talk about correlation. Okay, let me show you. The big topic is bivariate data. What is the meaning of bivariate data? Okay, before we were analyzing one single variable. For example, the height, the weight, or whatever we want, the number of cars. Okay, so we were using one single variable, and we were finding the mode, the average, the maximum, the minimum, the range, inner quartile range, or quartiles. Now it's time to use two variables at the same time, and this is bivariate data, when we have two variables at the same time. Okay, something that is super useful is to use the correlation. Let me show you. Correlation, it's a number that represents the relationship between two variables. That's it. Okay, it's going to show you, to tell you the relationship between two variables. For example, guys, there are different scenarios. For example, in this case, we have two variables, these exam scores, hours studied. And we have these three scenarios. We can have positive correlation, no correlation, negative correlation. I want to explain this. Let me show you where is this one. Okay, here. First, the correlation is represented by the letter R, okay? And the correlation is always between -1 and 1, okay? -1 and 1. So we can say that we have negative correlation and also positive correlation. I want to show you this. When we have positive values, we can have these scenarios. Positive perfect correlation when we have the R equals 1, a strong correlation, weak, 0. Okay, but also we can have this situation. Let me show you this. For example, in this case, when the points is going downward, they are going downwards. If you remember the slope is negative. We can say that we have a negative correlation. Okay, so summarizing, what is correlation? A number that is going to tell you the relationship between two variables. Okay, then, for example, this here. In these cases, we can say, okay, there is no correlation, okay, because we cannot see a pattern. For example, this one, we can see a pattern here, a positive pattern. In this case, a negative because it's going downwards. Okay, so the number, the R, is going to tell you if we have a positive correlation, negative, and also, guys, this is super important. We can use these descriptors. We can say if we have a value between 0 and 20 and 0.25, it doesn't matter that we have negative values here. We can say, well, we must say this is the correlation is negative or positive, depending on the case, and very weak. Or we can say, for example, we have a number between 0.5 and 0.75, we can say moderate positive correlation. So this is super important to use when we are talking about correlation. Before doing the example, guys, I want to show you that once that you already know that the correlation is a measure of the relationship between two variables, and we can use a number between -1 and 1, okay? And remember, if the R, the correlation, is 0, it means that there is no relationship between the two variables. I want to show you this example. Okay, these are ideal examples. Look at this. We have two variables. Okay, we have this, the phone battery life. This is your battery, and the messages sent. So pay attention. As you can see, the slope is negative. So obviously the correlation is going to be negative. Okay, but what is the meaning? Pay attention. If we increase the number of messages, and we have hundreds, if we increase the number of messages, the battery is going to decrease. Okay, so basically, the more messages, the less battery. Or we can say the less messages, the more battery. Okay, what about this? Imagine these three situations. If we are analyzing the hours studied versus the exam scores, we can have at least three situations: the positive, no correlation, or negative correlation. In ideal case, the more hours, the more score, and we can say this is a positive correlation. We need to find the correlation using a calculator. Okay, if the result is something like this, we can say, okay, the results are weird, so there is no relationship between the hours studied and the exam scores. Okay, so let me show you an example, because in this example, we are going to introduce a different name to, let me see, this one. Okay, guys, when we have this is example 1, school basketball coach kept a record of the numbers of games played and the number of points scored. So we have two variables. The first one, a number of this will be x games and then points. Okay, but we have here something new. Use Pearson's correlation coefficient. Okay, so guys, if we have Pearson correlation coefficient, is to find the correlation, or also we can find product moment correlation coefficient. If we have PMCC, okay, it means product moment Pearson's product moment correlation coefficient. Okay, this means find the correlation. So I want to show you how to use the calculator, okay, the calculator, to find this correlation. So once that you have your calculator, guys, we are going to follow these tips. We have go to statistics, we press execute. Then here, let me delete these values. Enter the first variable using the list 1 and enter the second variable using the list 2. So the first variable is going to be x, the second one, the points, y. So we are going to follow this order, 3, 4, 4, 4, 5. Okay, so we are going to add number 3. Pay attention, in this example, we never use the total. Okay, we are not going to use the total row. Then in the list, so as you can see, we already have games, the games using the list 1, points using list 2. Then we are going to follow this to find the correlation. So we have press calculations by pressing F2, then regression, this one, F3, then we are going to use X, linear regression, and here we have this one, AX plus B, okay, AX plus B. So we press this one, F1, so pay attention. The value that we need is R, the correlation, okay? We can use this one, these are the same steps to find the regression line, okay? In the case that you need the regression line, guys, in that case, you are going to substitute the A here and B here. The X remains the same, X, okay? So pay attention, let me delete this. So according to my calculator, this is R, 0.95. So we can say there is a positive, a strong correlation between the games and points. That's it. This is how can we find the correlation. the Pearson's correlation. But guess what? We have two kind of correlations in the IV. This is the first one. Pearson is when we use the original values like this: 3, 4, 4, 9, 10, 20, 16. Let me show you something. Let me show you this case. No, this one. Okay, we have a different kind of correlation. In this case, the Spearman's rank correlation. This is the second one. Let me explain the difference. Guys, when this, let me copy this. When the values, the data is represented by a curve, pay attention to these points, and remember this is a spiral plot. This is like a curve, okay? It's better to use Spearman's rank correlation. In a moment I'm going to explain you how to find this. If the points, if they are following a linear path, Pearson's correlation, it's going to be better to use Pearson's correlation. Okay, so again, if the points are following a linear path, the best correlation would be Pearson. If the points are following a curve like this, it's going to be better to use Spearman's rank correlation. Okay, so in a moment I'm going to explain you how to find this Spearman's rank correlation. Okay, first, to calculate this, we are going to use ranks. Okay, what is a rank? In a moment I will show you what is this. We are going, ranking is to put values in descending order. Okay, for example, this one. Guys, in order to find the Spearman's rank correlation, we need to build a new table. This table would be the ranks table. The second one, we have ranks table. This table, okay? So, what is ranking? First, guys, again, we have two variables, the x and y. So we are going to find out the relationship between x and y. And remember, if the relation is linear, if this is linear, it's better to use Pearson. If we have a curve, it's going to be better the Spearman. So what is the trick when we have the Spearman ranks correlation? First, we need to identify, number one, give rank 1 to the largest value. We need to identify which number. Let's focus on x, the variable x. What is the biggest number of this variable x? Obviously is 40. Okay, so to this number 40, we are going to say, this is my rank number 1. Then we are going to label every single number in descending order. Okay, something like this. Then what is the next number in descending order? 31. Then 25, 18, and 12. Okay, these are the rankings. But pay attention, for y, we have a trick. Because when we are going to do the ranks for y, again, we are going to identify the biggest number. The biggest number obviously is 14. So this is the rank number 1. But then this is the rank number 2. Here comes the trick. Because we have repeated the 9 and 9, we are going to follow the numbers that we have. For example, 1, 2, 3. So pay attention to this. If we have 1, 2, we are going to continue with the count. 1, 2, this is going to be 3, 4, than 5. But what is the trick? In our table, the new one, we are going to write down the rankings, the ranks in the same order. So for example, for X, we have 5, 4, 3, 2, 1. Okay, in the same order. But for Y, we need to do an extra step because here we have if we have values repeated, assign the average rank. Assign the average rank. What is this? This means you are going to check if these two numbers are repeated, use the ranks 4 and 3 and find the average between 4 and 3. In other words, we are going to say 4 plus 3 divided by 2. This is 7 divided by 2. Obviously, this is 3.5. This 3.5 is going to be the rank for these 9 and also these 9. Okay, again, we are using the average of these two ranks, not the 9 plus 9. Okay, we are not going to use 9 plus 9 divided by 2 because it's going to be 9. We are going to use the ranks. So when we are building the ranks table, we are going to have this order. We have 5, then 3.5, 3.5 again, 2, and 1. Okay, so this 3.5 and 3.5 is because the 9 and 9, they are repeated. So we need to assign the average rank. And be careful. In the case that we have 3 or more numbers repeated, we need to divide it by 3 or by 5 if we have 5 numbers repeated. Okay, but then what? If we have this new table, the ranks table, now we are going to find the R using the calculator. So we are going to do exactly the same as before, but now using the ranks table. So guys, to complete the example, what we are going to do is, okay, if we have completed the ranks table, the rankings table, we are going to use the ranks. Pay attention here. We have the ranks. So this is X and Y. Y would be the list number 2, following from your left to your right. And this is 2 and 1. And we are going to find exactly the same R. Again, we are going to use calculations, regression, linear regression, AX plus B. These are, we never use R squared. These are is going to be the Spearman's rank correlation. Usually, when we write down this, we use RS. We say RS, something like this, RS, to represent or to say that this is the Spearman ranks correlation. Okay, so summarizing, guys, if you use the original values 12, 18, 25, 31, 40, and so on, you are going to find the Pearson correlations coefficient. Then, if you perform the ranking thing, if you assign the number 1 to the biggest number, and then using the descending order, you are going to find the Spearman ranks correlation. Okay, and that's it.